Good morning. I am Ms. Page, and today we're going to talk more about graphing rational functions, ones that are more complex than what we started with, where we have holes again, but something a little different happens. We get lines with holes, and also where we have two vertical asymptotes, and we may or may not also have a hole in those cases. So our procedure is basically the same as we discussed in the previous lesson. So we want to simplify our function, we want to find the coordinates of any holes, we want to find our vertical and horizontal asymptotes, zeros if they exist, a y-intercept if it exists, and see what we've got. And then more than likely, depending on what we're graphing, we will sometimes have to find other points, or in the case of a line with a hole in it, we will use our knowledge of graphing lines to get more points. All right, so we are going to take a look at this example. So to begin, we are going to simplify our function. So we are looking at factoring the denominator. GCF is 1, so in this case we're going to get an x plus 4 times an x minus 1. So it's very important not to make assumptions here. Like we might expect to get an x plus 1, but we shouldn't assume. Because if I look at my factoring, I need these signs to get a positive 3x in the middle. So I actually have no common factors. So we've learned that means there are no holes. So the fact that the next thing we would look at is vertical asymptotes. So our vertical asymptotes, we actually end up with 2. One from each of these factors that involves x. And so this one is going to give us a vertical asymptote at x equals -4. And this one is going to give us a vertical asymptote at x equals +1. Horizontal asymptote, we should go back to the one where we're in standard form. Can't use our factored form to figure out a horizontal asymptote. So the ratio of the first terms when in standard form, we'd take x over x squared. And that ratio is going to reduce to 1 over x. So because there's an x still remaining in the denominator, the horizontal asymptote stays at the x-axis, which has the equation y equals 0. All right, 0. You can use either form really, but we'll use the simplified form like we've been doing for our 0. So to find our 0, we know that y, which is f of x, would be 0. So I've got 0 equals x plus 1 over x plus 4 times x minus 1. I'm going to multiply both sides by the factors in the denominator. And that's going to give me 0 equals x plus 1, and solving for x gives me x equals -1. So that -1 is our 0. The other thing we should look at is a y-intercept. So for y-intercept, we know that x would be 0, and we're solving for y. So I could use either form again, but I'm going to use this one. So I have my y value would be equal to 0 plus 1 over 0 plus 4 times 0 minus 1. This would be 4 times -1. So I get 1 over -4, which is -1/4. So this gives me the ordered pair 0, -1/4. All right, so now what I am looking at, sorry about that. Now what I'm looking at is making my axes. And in making my axes, probably going to the middle is going to be fine. All right, so I'm going to put some numbers on these axes to help me with graphing accurately. All right, and my asymptotes. So now graph those as dashed lines. We have two verticals, one at x equals -4, so it's going to cross the x-axis at -4, and another at x equals 1, so it also crosses the x-axis at +1. And then our horizontal asymptote was y equals 0, our x-axis. So you can put a dashed line here, or just remember that's your horizontal asymptote. Then we're looking at graphing points for each of the pieces. Now we're going to get 3 pieces. We're going to piece over here to the left, in the middle, and over here to the right. So my 0 helps with getting a point for the middle piece, but it's actually not enough for my middle piece. My y-intercept is also going to be in this middle piece at 0, -1/4, which is right about there. So we're going to have some work to do here to find a point for the left piece, a point for the right piece, and we can use one more point here at this point to verify if the curve is going to go up and down in the middle, or if it's only going to go down in the middle. So given my domain here, so these are my other points that I'm going to need. So I would pick -5 over here for the left. So I'm going to let x equal -5. And using my simplified function, the y would be -5 + 1 over -5 + 4 times -5 - 1. So this is -4. This is going to be -1 times -6, which is +6. So this is going to reduce to -2/3. So this is the point -5, -2/3. So graphing that, it ended up right about here. So that tells me that I'm going to be down in this section, approaching the horizontal asymptote of the x-axis and the vertical asymptote as so. I'm going to pick one more point over here, or find one more point over here to help me with where it's going to go after this. So I'd pick -2 or -3, whichever one kind of preferred. I think I'm going to go with -3 in this case. So this is for the middle. So x equals -3. So the y value would come from -3 + 1 over -3 + 4 times -3 - 1. The numerator would be -2. This is 1 times -4, which is -4. And this would reduce to +1/2. So this is going to give me the point -3, +1/2, which tells me it's right here. So it's going to go up over here on this side. So what I get is this piece of the curve goes up like that, swings through its 0 and y-intercept, and heads down towards the other vertical asymptote like that. Now I need one point over here on the right to figure out if my piece is above the horizontal asymptote or below it. So for the right piece, I'm going to let x equal 2. And so then calculating my y is going to come from, just lost my function, okay, there I can use that, -2 + 1 over -2 + 4 times -2 - 1. The numerator there will be -1. This is 2 times -3, which is -6, and so that becomes +1/6. So this point is 2, +1/6. And that goes right here. So that tells me it's above the horizontal asymptote at the x-axis, and it's going to curve through like so. Got a little bit close there. Let's try that again. Like so. And that would finish the graph, all of its pieces. All right, so let's take a look at the other type of problem we're learning how to graph today. This one right here. So here we're looking at Again, simplifying, so that would be what we would do first. And so I can factor that numerator of trinomial with a GCF of 1 into x minus 4 times x plus 3. And the denominator has a GCF of 3, and that gives me 3 times the binomial of x minus 4. So x minus 4 is a common factor. And so my simplified function is f of x equals x plus 3 divided by or over 3. There is a whole. And remember, the x-coordinate of the whole comes from what we got rid of, not what's left. So that x minus 4 tells us where we have the x-coordinate. Adding 4 to both sides gives us x equals 4. And then plugging in the 4 to our simplified function will give us the y-coordinate. So that would be 4 plus 3 over 3, which is 7/3, which is 2 1/3. So I'll just write it that way. You can write it at 7/3 also, that's fine. Now here's what's different about this one. So next we would normally go to our vertical asymptote and then our horizontal asymptote. But we no longer have a variable in the denominator. And so what that's telling us is that this is not going to have any asymptotes at all. This is actually the equation of a line, but not in its normal, what we call slope-intercept form that we graph from. But this denominator of 3 is the denominator of x and the denominator of this plus 3. So when I look at it this way, what I'm going to get is f of x equals x over 3 plus 3 over 3. And this gives me a coefficient of 1/3, which is the slope of a line. And this is our y-intercept, which would be a positive 1. And so we're actually graphing a line with a slope of 1/3, a y-intercept of positive 1 that has a hole in it. All right, so that's what we're going to graph now. So we need our axes. Some numbers on here for reference. All right, so we are looking at, again, so this is a line. Its slope is 1/3. So that positive 1 means we're going to go up 1, and the positive 3 means we're going to go to the right 3 from our y-intercept. And our y-intercept, like if x is 0, y would be 1. So we have 0, 1. So 0, 1 is my y-intercept. And my slope is 1/3, so up 1 over 3 would put me right there. And up 1 over 3 again would put me right there. But I can't just draw in my line like I did in Math 1 because I have this hole. So now I have an open circle at 4, 2 and 1/3, which should be in line with these other points. And if you'll notice, 2 and 1/3 right about there, which is going to put it nicely in line for the line we're graphing. And then we're going to draw our line. So I think I'll use my tool here. So this piece. So from here, it's jumping over that hole and going that direction, or jumping over the hole and heading this direction, like so. And that completes the graph. So those are the two types of problems in this lesson that you will be practicing in your assignment to graph completely. All right, good luck.